So what we have to do first, the motion path is already controlled by keys. So we need to break the connection on that. Now this, it will no longer work, but we're now saying we don't want it to be controlled by the time slider, we're going to control it by something else. So let's open the expression editor, animation editor, expression editor, expression name, and down here we can start to build an expression. And what this will do is an expression will be querying the scene all the time and updating things constantly. You can change all this using these values when it's evaluated, so on demand, or whether it's always running. And in this instance we want it always running, because if somebody's interactively moving this curve, we want to know that we want it constantly checking where it is, so it knows where the track is. So let's first bring back the controls, because what we want to do, we want this to drive the position. So track left underscore control is what we need. So excuse me. Right, to make this easier for ourselves, so we're not constantly repeating values, we're going to grab the values at the start of the expression. So we set this as a float because it can be a floating point number and not a solid number. We'll give it a name, left track Z, because it's going to be pulling in the position of where the left track is. So this is basically saying give me the Z position of the track. Next we want the curve length. And notice we're giving everything a unique name, left, because we're only working on the left side at the moment, and when we do the right side later, it's handy to have everything have its own name so you can distinguish left and right, and the expression doesn't get confused about what objects or variables it needs to use. So this will pull in these values for us and put them into these variables, so we can pipe these directly into the maths. Now what we need to do is work out where the track should be using that bit of maths that we had before. So let's call this left track position. So this is the bit that we're putting in. So let's just copy that. So Maya won't recognize these, but we've told it that should be that. We know that pi is a number 3.14, and now we know what the curve length is. We can put that into there. So this is just because these are in these variables, this is just querying things and building and putting things into these variables. So this is going to query all this, put it into this variable, but we're currently not doing anything with it. But this is where we tie this in. Now we've worked all this out, we can tie this into the motion path. So we know the name of the motion path attribute we want to edit, U value. So we're basically saying that U value is this left track position. So let's give this a nice name, call it left thread exp create. Now that's created the expression. So if we close that down, now because it's tied to this, if we move this in the Z, you see this is now moving around the curve just as we need, but it's just too fast and it only loops once. But we have the basis of the expression we need. We just what we need to do now is add a bit more information into it so that we can expand a little bit more and possibly adjust the speed and get it to loop as well. So let's add in another variable. This will determine the speed. You can play around with these values to get the right speed you need, and what we need to do now is change this command here. What we're going to do, let me just put this in. So if we give this a try, as you can see it's moving a lot slower now. It should hopefully, there we go. Now it's not moving with the curve, but as you can see, if I move forwards and backwards it's looping, and this will do it forever. So that's exactly what we need. So what did we do? We added in a track speed value. This determines how fast it's going around the track, and then what we've done here is we've added in this modulo operator, which is a percentage sign, and what that does is it will give the remainder of the division of two values. So it's dividing the track position, which is the Z, no, which is this, which is finding out where it should be around the curve. It's dividing that by the speed. And what this will do is it'll always give a result between 0 and 1, because the U value on the motion path only goes from 0 to 1, the start and the end of the path. So what this does is it will, in addition to this, and when we divide it by the tread speed at the end as well, this will just give it a constant loop of 0 to 1. It'll, no matter where the Z value of the curve is, it will always be giving you back a 0 to 1 value to pipe into the U value. So this gives you the loop. As soon as it gets to 1, these two are dividing by each other again, and it's going back to 0. So this is what gives us the loop that we need, and this gives us the track moving around the curve. Now this still does have its problems. So we've eliminated the need for the time slider, which is good, and it works fine off here. But if you notice, if I bring back the grid, when you go into a positive world space, it works fine. As soon as you go into negative, nothing. Doesn't work. So we need to have a look at fixing this now, and again we'll add more into the expression editor. So what we need to do, we need to check whether it's in positive or negative world space, and we have another value on here that we can change, and that's 360 there. So what we need to do is say if the main controller is in positive world space, move in this direction. If it's in negative world space, change to another direction. So let's add this another piece in, another piece of code in. So again, we need a variable, and this is going to be a solid number because it's going to be 360, or we'll change it to minus 360 depending on where it is. We'll call this tread direction. And we're not giving that a value yet because we need to determine where things are. So I'm going to add in so if the position of the left track is less than 0, which means it'll be in negative space, we want it to tread direction is going to be minus 360. Then we'll add an else command. This means if it's greater than 0, do this instead. So tread direction, so this will check if the Z position is less than 0, so it's in a minus value, tread direction is minus 360. If it's in a positive value, tread direction is 360. We also need to remember to change this down here so that it's using that value rather than a straight number. Click edit, that should have updated. So now it still works in positive and it's working in negative, but we still have a problem. As you see, it's still working, but it goes in the opposite direction. Now we can fix this again. But before we do, basically we need to add something else onto this curve. But at the moment it won't work because we need history on the curve. But luckily we're going to add that now. What we're going to do is add in controls so that these wheels, as we can actually move these around and they will interactively move the curve. So you'll get sort of a more fluid movement as the track drives around. So we'll have a quick break and we will look at that next.